All right, I want to show you some very nice ways to look at these ransomware attacks. So let me start with the home search page in Splunk. I was very pleased to get this working. So we're going to start with the same thing we've done before, just looking at the server events in Shurikata. So the source type is Shurikata, and I just look for the word server, and I look for that over all time. And the only thing I really want here is I want to know the timeline of the attack. So here's the timeline. It started on August 24 at 9:49 a.m. and ended at 10:15 a.m. So I make a note of those times. And now I can find out all the commands that were executed. If I go to back to the search home and look at the Sysmon data, make my screen big. Yes. Okay. I go to the Sysmon data. And I think I'll turn on some sampling to make it quicker and go to all time. All right, now the Sysmon events that create a new process have a command line. And this command line shows you exactly what command was executed, which is pretty awesome. So I just want to look at events with that field. All right. And now I can just make a table of these things, of time and command line. So I put this in, pipe table time and command line, and run that. And I'm down to just 73 events, but I'm sampling 1 to 10. So let's end all event sampling. And now I have all the command lines executed on all the Windows computers that are monitored here. I could restrict it to just the one computer of interest, but I don't really have to because the time restriction is all I really need. I know that the event was from 9:49 to 10:15 a.m. on August 24. So when it finds them all, which will be another few seconds, there. Now I can sort them by time. And so here I am on August 10, which is too early. So I'll just skip ahead a few pages. I'm still on August 10. Now I'm on August 24 at 9:09, and I know the event started at 9:49, so it's around here. There's 9:06. Looks like this whole page is before the event. So let's try the next page. Okay, here's 9:26, and if you just sort of scroll through it, looking for anything strange, we're not quite late. Now here's the one. This one just stands out like a sore thumb. On 9:43, this crazy command got executed that's so big it won't even fit on the screen. This is obviously part of it. In fact, you may remember this from that open source intelligence. This is part of it, app data random. This is a Windows shell script that creates a VBS file. This is part of the ransomware attack right here. And if you just scroll back up and look at the earlier events, you can see exactly what happened. This person opened a thumb drive, drive D, with a Microsoft Word document on it called Miranda Tate Unveiled.m. They opened this file. That then turned on some Office protection platform, which apparently did not work. And then it launched some processes. Here is where it launched WScript on a Visual Basic file that it found in that document. This is the script that was inside the document, the Visual Basic macro, and this then ran this command line shell, which created another VBS with a random name. And that's down here a little further. You'll see it, yep, that thing created something called 12124.temp. And it's even easier to analyze if we add the parent command line here. So let me do that. If I can spell it right, I can just put it right here this way, parent command line. All right, that's good. It'll take a few seconds to run, so I'm going to copy this and put it in my notes. It's 700 and something when it's done. Okay, 726, 767. All right, I sort by time. I just go to the right area, 949. Okay, and let's restrict it to the right day. I'm going to restrict it to August 24. All right. $379. All right. Now I sort by time, and this is now going forward, and I want to start at 949, which is going to be here. Okay, so here we are. There's that script running, and we can just follow the steps here. Let me make my font a little smaller. Okay, so if I go back to, it starts at the end of the previous page. I think I better leave it bigger for people to see. All right, so here is the original event that started all the problem. Here is where it launched the Microsoft Office, Microsoft Word opening this .m file. All right, and that then became the parent of a later event. That launched, okay, let me try to get rid of these extra windows. All right, that was the Word launched. Then down here, it launched this CMD, and I'm not seeing the one in between, but let's keep going. This is the W script that launches 2049, and then the 2049 okay, there, I'm getting a 943.21. Anyway, I'm not quite able to make a beautiful, pretty picture here, but here's the .m launching that CMD. And let me see, my time is the wrong way, maybe. 43, 27, 54. Nope, it's forward. All right. Don't quite know why things aren't quite in order, but the Microsoft Office document launched this thing. This thing created a W script file and an SPL wow file, whatever that is. And then this thing launched that thing, creating 1214.temp, and what's happened here is it's been only a few seconds. Now it's going to run W script and create this 12124.temp file, which will then run for a while. Then it creates a delay here by pinging the loopback address once, and then it's going to run this thing, launch something called ask, still at 948, Then it's going to call the adapter troubleshooter, which is checking your network connections to see if it can find shared folders to encrypt. And this is being done by Explorer. And then it's going to run the adapter troubleshooter, find network shares, and start encrypting them. It deletes the local shadow copies. It changes, this is still deleting shadow copies. Then it changes to prevent you from changing the boot up menu, because it's going to trash this local workstation, forcing it to boot up showing the ransom note. And this is ask.exe doing that, turning off recovery, so the boot up recovery will no longer work in Windows. And this is all at 9:49. So first it trashes the local workstation, and then it spends the next half hour encrypting files on the network. And you see here, it's finding files. It's encrypting his local files, D, work stuff, PDF, and you can just watch it step by step. Watch it go through the network doing bad things. And when it's all done, then it pops up the ransomware, which is going to be up around 10:15 on the next page. And we will see that pound at the top of this page, 10:15. There we are. This is something else we saw in the open source intelligence. It has this decryptmyfiles.vbs, so you can see the whole process right here. And that is the joy of Sysmon. With the command line and the parent command line, you can trace down exactly what happened, where it started and what it did. And notice when it's done, it has a delay and it kills the ask task, and then it's going to delete the files, so it cleans up after itself. You can see it run the ask process to do all the encryption, then kill its own process. All right, and that's what I wanted to show you.